Greetings and welcome to my new calculus channel. My name is John Gabriel. So let's talk about this video that was published yesterday. Okay. And several others, such as Cauchy and his definition of the derivative. Okay. It's very important stuff because whether you like it or not, you're still using it today. Exactly the same ideas of Cauchy are how you define your mainstream derivative. Okay? There is no difference. It's just clothed in a disguise of epsilonic and delta or epsilon delta inequalities. Okay? That's the only difference. It's still the same wrong, incoherent, non-rigorous BS that Cauchy and Weierstrass got together and decided they were going to leave as a gift to the rest of the world. Okay, so they and not the mathematicians, excuse me. This is a very touchy subject. Let's just deal with a comment quickly. This guy here says, and I'm cherry picking a quote from a French mathematician. No, I'm sorry, Cauchy was not he was not a mathematician, because in order to be a mathematician, you need to produce great works. I don't know of anything that Cauchy produced that I would consider great. Okay, so his line integral might seem like something great, but in my opinion, it is not something great. Okay, and nothing else that Cauchy did was remarkable. So I wouldn't have called him a mathematician. It's like calling that little dimwit Terence Dow a mathematician. He's a moron, not a mathematician. He's a moron with an IQ less than 120. Okay, if that, right? So you do not get to call yourself a mathematician unless you produce great works. I'm very sorry, but getting a PhD in mathematics does not make you a mathematician. You don't get to call yourself a mathematician by writing a silly essay, which is, well, of approximately 100 to 200 pages, or let's say a small novel, because most of it is bullshit, and peppering it with citations from other morons. That just doesn't allow you to be called a mathematician, okay? It's just total, absolute, incoherent nonsense, okay? Now, where am I going with this? Let's see where I'm going with this, because what I'd like to do is clear up a few points about continuity, smoothness, etc. So this guy writes, smooth and continuous is taught as a condition for a function to be differentiable in schools across the world. So that's already a statement that shows he clearly does not understand, and the rest of the world also does not understand these things. If you say smooth, then continuous is redundant. Do you understand that? Okay. So it's not necessary to say continuous and smooth and continuous, or even, well, you could probably get away with saying continuous and smooth, because although a function can be continuous, in order to be smooth, it has to have another property, which I'll explain all these things in a moment. Okay. So let me explain that while I'm at it right now. And yeah, let me just do that. There's so many things that are on my mind. It's going down about 2,000 paths. All right. Anyway, so in order to be continuous, a function must be defined everywhere, and there must be no disjoint paths. What does that mean? That means that if you have something like this and like that, okay, it's not continuous here, all right? Geometrically, that's all it means. It doesn't have any disjoint path. So if you take a certain interval and you examine that interval, then there is no disjoint path. Okay, so that's what it means for a function to be continuous. Continuous. One, that's continuity. Not the drivel that you find in mainstream uh, textbooks and lemmas using epsilon deltas. That's all just absolute BS. They've totally confused themselves. Even they're such morons. They don't even understand it. Number two, we go from continuity to smoothness. But before we do that, we need to define tangent line. Okay, so this is very important. What is a tangent line? Okay, tangent line. So now let's clear some space up here because I don't have a very big board. Now, Apollonius, the great geometer of over 2,000 years ago, and I'm giving you a free article here, by the way. He actually proved. Well, he didn't really define he didn't produce the first definition, but he proved that a tangent line may not cut a curve. It may not cross a curve at the point of tangency ever. He proved it, by the way. And how did he do that? Well, it's in a very famous work of his called The Conics of Apollonius. Okay. Now, most mainstream mathematics academics wouldn't even be able to get through 3 pages of this stuff. It's just too advanced for them, even over 2,000 years later. Okay? So let's see what he says. He says, if a straight line be drawn through the extremity of the diameter of any conic parallel to the ordinates of that to that diameter, the straight line will touch the conic and no other straight line can fall between the conic. Okay, so what he's showing in steps here, and I'm going to let you read it in steps, is that you cannot have a tangent line crossing at the point of tangency. And he proves it for several points. And then you might turn around and say, well, he was dealing with conics. Well, guess what? Every curve that you can think of can be broken down into a representation by conics. Every curve. Okay? There's no curve that cannot be. Of course, it has to be smooth, but we'll get to what the concept of smoothness is in a moment. So a tangent line, as what the brilliant ancient Greeks, my ancestors, told you, is this. It's saying that if you have any function and a tangent line like that, it will meet only at that point and it will never cross at that point. Okay, and they proved it. It doesn't matter if it's a conic or any other curve, because even if you have a cubic or something like that, or like that, any other curve is expressible in terms of conics. So it applies to every function, not just conics. Okay, and so to be a tangent line, it must touch at one point and never cross at this point. Okay, it must extend to both sides and never cross at this point. Then, because the absolute morons of mainstream mathematics academia didn't like the fact that you cannot have a tangent line at inflection points, they placed this entry in one of their articles. It says, an 1828 definition of a tangent was a right line which touches a curve, but which, when produced, does not cut it. This old definition prevents inflection points. You know who taught them that? I did, by the way. They found that out because from my new calculus, which does not allow inflection points, tangent lines at inflection points, and it's not a problem at all, by the way, because the mean value theorem, which is the fundamental theorem of calculus, does not care about inflection points. It works whether there is inflection point or not. And it says this old definition prevents it from having any tangent. Notice the arrogance of these fucking nincompoop idiots. It has been dismissed, and the modern definitions are equivalent to those of Leibniz. And now, get this, who defined the tangent line as the line through a pair of infinitely close points. Leibniz was just a stupid bum, okay? Didn't know anything about calculus. I mean, he was groping around in the dark. He tried to find a constructive definition of derivative. He fell on his ass badly, okay? Just like Newton did. Newton at least wasn't, well, Newton also had problems. So this is their definition. The tangent to a curve at a point P on the curve is the limit of the line passing through 2 points of the curve when these 2 points tend to P. Well, points don't tend to anything, by the way. and and on a smooth function, it doesn't even matter if that function is defined at the point of tangency. So there is so much wrong with the BS that you are taught in mainstream calculus. Okay, I'm not saying that the results don't work. I have never said that. The theorems that have been used in calculus work, but the theory which is used to explain those theorems is one big mountain of shit. Okay, it's all flawed. Every single bit of it. I'm telling you the truth because I know better than anybody else. So let's click out of this pathetic site, Wikipedia, because it's written by morons. Coming back to this, you can study this article, okay, and it shows you, and there's another one also on here on my academia site, which these articles are free. There's a lot more that I don't share, but what you need to know is inside there. Now, getting back to my uh, explanation here. So we've defined continuity, and now we know a tangent line is simply a line that touches at a point of tangency and never crosses at that point. What does it mean next to be smooth? All right, so now we're going to look at smoothness. Okay. So smoothness, and this is all geometric, by the way. Did you see me use any crap like epsilon deltas or continuity theorems or anything like that? Nope, I didn't. Okay, because those are all garbage. Now, what does smoothness mean? So we talk about smoothness over an interval. Okay, so let's just take this interval here like that. So we talk about the curve being smooth over this interval. What does that mean? That means that if you take any point in this interval, any point, it means you can draw exactly one tangent line at that point, not more than one. So if you have that silly function mod x, you can have many tangent lines there, okay? Many, because this here is not really one function. It's not really one rule. It really breaks down into two functions. And of course, what I'm telling you is that unless you have smoothness, you can't use calculus. So all those super tricky questions that they give you in your exams with mod functions, is it differentiable at this point? Anything? They're totally irrelevant. They're wasting your time. Okay, totally wasting your time. You can't. This doesn't even have anything to do with calculus, right? You need smoothness. Okay, but I haven't defined smoothness completely yet, so I'm almost there. So at any point, you only have one tangent line, okay? That's what it means to be smooth here. Now, there's only one exception to this rule, and that's if you have an inflection point. So let's say you have an inflection point there where there is no tangent, okay? But we don't care about that because at that inflection point, concavity changes. And there's another reason why we don't care about that because, as I mentioned earlier, the mean value theorem, the mean value theorem does not care about inflection points. Okay, doesn't care about inflection points. It's all right. So if you have an inflection point in this interval, it's okay. It's still smooth. It's still considered smooth. All right. And the mean value theorem, which is a fundamental theorem of calculus, which states, by the way, the mean value states this. Believe it or not, it states. It states. It states this, which is the fundamental theorem of calculus. Okay. This guy here is the arithmetic mean of all the ordinates of f prime in the interval x to x plus h. Okay, and I've discussed these things before. So I've given you now what the definitions of continuity are, tangent line, and smoothness. Let's get back to these comments. So every now and again, idiots get on here pretending that they know better than I do. It's kind of annoying when one knows. I'm a genius, by the way, so I know these things are correct. People get on here and they try to tell me, that they know better. It really pisses me off sometimes. I mean, most of the time I just ignore it because I know they're idiots. But sometimes it can get to you, when people tell you, oh, you don't know what you're talking about, and some little wanker gets on here and says this and that, and oh yeah, and you're asking for money and blah blah blah. listen, go fuck yourselves. You don't have to watch my channel if you don't want to. And if you're one of those who post those comments, I would prefer that you didn't, because in Greek we have a saying, onon noito. And what that means is he who is able to understand, understands. The majority of you will not understand because you're idiots and your brain has been brainwashed. Okay, it's like a Trump supporter. It doesn't matter how many facts you produce to a Trump supporter, how many times you tell him that their crime boss, Trump, is lying and he is a criminal and a psychopath. They don't get it. They will instantly dismiss anything negative you say about their Jesus, their orange Jesus. Okay, there is no way you can convince stupid people, and the majority, 99.999% of your math professors and teachers are no different to Trump supporters, where mathematics theory is concerned, where correct mathematics theory is concerned. Okay, so I'm a little out of breath again. I'm having some lung issues once again. That's bad. I'm going to let you go now, but before I do, please click on the join button, and for just 4.99 euros a month, you can have access to a lot more than I've just given you. Okay, a lot more stuff than I do not share with non-members. Become a members only subscriber, and you will have access to all these things, including to my most recent projects, which is learning the correct way. Okay, so in this, you'll have access to a members only folder, this members only folder, if you choose to follow me. And there are lots of goodies in there, and I will be adding more goodies, provided I'm still alive and my eyes work and I'm able to breathe, etc. Obviously. So don't delay, become a member, and also subscribe to my channel, and also click like and follow me on academia.edu, where I have hundreds of fantastic articles, okay, that you can read and study and become wise and not remain an idiot like your math professor or teacher. I'm John Gabriel. This is New Calculus Channel. Good.